Hi everybody. In this video, we'll be doing our first proofs about the various edit functions we've worked with, proving validity. Let's start with defining validity, make sure we're on the same page about that. So we're going to say a list of edits is valid for some source and target strand if when you apply those edits to the source strand, you'll get a result that's equal to the target strand. Right? So these edits are valid from source to target if they actually get you from source to target, right? This is sort of, to me, sort of the fundamental correctness property of any of these edit generating functions is some kind of validity notion like this. Now you might look at this and say, well, Prof. Greenberg, why don't you just use equals? Isn't that easier? And it turns out that for some of our later proofs, it's a little bit simpler to use this computational notion, right? It ends up just making our goals a little simpler and some of the reasoning a little bit easier, at least in my opinion. So we'll use this one. But look, we've proved a lemma, EQ strand if and only if, right? We've already proved something that says these two definitions are really equivalent. So it can't be that important which one we use. And I think this one is marginally more convenient. So we'll use that one. Okay, so what are we going to prove? We'll start off with some fairly routine inductions, exercises for you, proving our various components correct, right? Delete edit really produces correct edits to go from a source strand to nothing. Add edit really produces correct edits to go from nothing to a target strand. Copy edit, right, this new one that I've shown you, really produces valid edits to do nothing. We'll see why it's useful in a bit. Okay, that's just sort of basic checking your work. Now let's prove the actual interesting edit generating functions valid. So delete add edit, naive subedit, and Levenstein. These are the interesting functions that we care about. Delete add we'll start with. We want to prove that for any source and target, we'll get valid edits out of delete add edit. Now you might think, well, that should be easy. I'll just use delete edit valid and add edit valid and I'll call it a day. And that's like almost correct. That like almost exactly works. It doesn't quite work. It's possible to do this proof without a helper lemma, but I think it's much easier to do it with one. The helper lemma, the hint I'm going to give is that you want to prove something about how delete, edit, and append interact. So my advice here is, okay, try it on your own, see if you get stuck. Maybe you'll figure out there's a sort of like clever kind of sideways solution that avoids the helper lemma, but maybe you'll get it, maybe you won't. Spend a bit of time on it. Give yourself, say, 20 minutes, maybe using admitted to sort of explore helper lemmas to see which actually let you prove your goal, like I did in that other video that I recently added. So check that out. And if you're stuck after you've given it a solid 20, 30 minutes, then bring it to Zulip. I expect we'll have conversation on Zulip about this, and that's great. But see if you can get it on your own first. Okay, that's the first one. This one's tricky because of this generalized helper lemma. The next two, proving naive subedit valid and subedit valid, is actually, I think, a little bit more straightforward because these are slightly more straightforward recursive functions. So a direct induction should more or less do you. Subedit's a little bit harder than naive subedit. Okay, once you've done all of these, then you'll be ready for the next section where we prove Levenstein is valid. All right, that'll be the next video. Cheers, y'all.